Welcome back to Applied Materials and Corrosion. Here I'm going to measure the voltage and current between an iron electrode and a copper electrode. The copper electrode is in this copper nitrate solution. The iron electrode is currently in buffer 10. I'm going to apply various voltages and try to make the iron dissolve. And we will look at the current while it's doing that. So the power supply is on the right here, and the voltmeter is on the left. We will turn up the power supply, which will effectively force the iron electrode to dissolve, even though it really doesn't want to, and it will push it up outside the passive area where it is until it eventually passes some current. After that, we'll go to a different pH. We're going to go to pH 4 and do the same thing, and what we will expect to see is much more current at the same voltages. So we can compare those to each other in a bit. I'm going to stop here and zoom forward because I think I messed up the first run. So I'm going to cut a bit out and we'll come back to it as we get back into the same bit where we're all connected up and it's working. So here we are back, and we've got a very small voltage, 1.6 volts, and we've got 1.8 or 18 milliamps, and we're gradually turning it up, and the current is going up equally. It's not going up very much. We've got a relatively low current, so we can see, let's take it at 5 volts, we've got 53, and if we take it at maybe 10 volts, we will see that there's about 100 milliamps, and then we can see it at the top. As a quick mental comparison, you can do a graph if you wish to at another time. So here we've got the equivalent of 10 volts, and we've got 90 milliamps, and if we carry on to the maximum that this power supply will do, we'll see it goes up even more. Obviously, that's not surprising. We will get up to much higher value. I'm trying to turn it up at a constant rate, but obviously it's by hand, so that it's not super accurate. But here we are, 20.8194. Now turn it all the way back down, and it gradually goes back down. So there appears to be a little bit of sort of resistance in the system, but then we get down to the same value as before, very low current. And here we are at pH 4, same conditions, same piece of iron, slightly cleaned again to try and get it to work the same, because we would expect some kind of oxide layer on the surface. So I've cleaned it and put it into the pH 4 buffer. We get some current immediately. It's more current than we would have expected, or than we saw at naught on the other electrode. So we've got 12 milliamps, and we had very even less. So we got 12 milliamps, and we saw none at all before, not 0.01 or something like that. So 1. Now we turn it up to what did we have? So 1. Let's see, at 5, I think. 3, 4. So at 5 volts we got 75 milliamps. At 10 volts we'll get a higher value. Remember, we were at 90 something and we've already passed that. So at 10 volts we get 130, something like that. It's a little bit quick, so I'm not quite sure what it was. I'm not going to go back and see. You can go forwards and backwards, or put it all on a graph to see the difference. As we get up even higher, we were going to the maximum. I can't remember what the maximum was now, but I know that this one is significantly higher. So that's the maximum voltage. We've got 257 milliamps. As we turn it down, we see, similar to the other one, there's a bit of lag. It seems to go down quicker than the other one, which is reasonable, because we would expect there to be less of an oxide layer on this one, because it's dissolving straight into the pH 4 buffer. And again, we get back to the position that we start with, which suggests that we haven't broken anything at all, which can happen. We can generate a layer that doesn't go away again.